This video is all about tangent lines, so ultimately I will show you how to find the equation of a tangent line at a given point. But first we need to review simply how to evaluate the derivative at a given point, because that's going to end up being the first step to finding the tangent line equation. So of course we need to find the derivative. To find the derivative, let's do the product rule, where the first time through we take the derivative of the first factor and leave the second factor alone. So the derivative of sine is cosine. That's just something you memorize. And for this first pass, we leave the second factor alone. So sine x plus cosine x. And then we put a plus, but this time through we leave the first factor alone and we take the derivative of the second factor. So leaving the first factor alone, we have sine x, and taking the derivative of the second factor, the derivative of sine is cosine, but then the derivative of cosine is negative sine. This is the derivative, and we need to evaluate this at the point pi over 4 comma 1. But that really means evaluate at the x value of pi over 4. So just remember that both the cosine of pi over 4 and the sine of pi over 4 are equal to radical 2 over 2. So let's make that substitution. So we have this. But notice at the end here we have radical 2 over 2 minus radical 2 over 2. So this is 0, which will make this entire term have a value of 0. So we can disregard that. But if we add radical 2 over 2 plus radical 2 over 2, that is 2 radical 2 over 2. And of course these 2's are going to just cancel each other out. So that's going to leave us with radical 2 times radical 2 in the numerator, which is just regular 2. And then we still have this 2 in the denominator. So that's 2 over 2, which equals 1. Okay, let's find the equation of the tangent line to this function at the point 1 comma negative 5. When we write the equation of the tangent line, we will use point-slope form. So that means we need two things. We need a point and we need the slope. We already have one of those things because they give us the point of tangency. So that's the point that we need. So really, all we need now is the slope. We know that if we have the derivative, that will be a formula that gives us the slope at any point. So that's our next step. To find the derivative, we will once again use the product rule. So the first time through, we will take the derivative of the first factor and leave the second factor alone. But the derivative of x minus 2 is just 1, which we didn't really need to write. And we're going to leave the second factor the way it is. The second time through, we leave the first factor alone, so we just write the x minus 2, and we take the derivative of the second factor. So power rule, that 2 comes to the front, we have 2x, and the derivative of a constant is nothing, so there you go. This is the derivative. So now we need to find the slope at x equals 1. I'm saying x equals 1 because that is the x value of the point of tangency. So we are evaluating the derivative at 1. So substituting 1 for all of these x values, we have 1 squared plus 4 plus 1 minus 2 times 2 times 1. So this is just 1 plus 4, so we've got 5. And then 1 minus 2 is negative 1 times 2. So this is really just 5 minus 2, so this is 3. So we had a point from the start, and now we found the slope, which is 3, so we are ready to write the equation of the tangent line. So we do y minus y1, since it's minus negative 5, so I'm just going to put y plus 5, is equal to the slope times x minus x1. So x minus 1. So that's it. This is the equation of the tangent line at the point 1 comma negative 5. Let's do it again. So we have a point, but we need the slope. To find the slope, we're going to take the derivative. We're going to end up using the quotient rule. So here's the quotient rule poem. Low D high, less high D low. Draw the line and down below, the bottom squared will go. Soak that in for a second. When I say D high, I mean the derivative of the top function. When I say D low, that's the derivative of the bottom function. So the poem starts off low D high. So low means the x minus 3. The way it is. D high means the derivative of the top part, but the derivative of x plus 3 is just 1, which I didn't really need to write. So it's low D high less, meaning subtraction, and then it's high D low. So of course high means the top part of the function the way it is, and then D low is the derivative of the bottom part. And the derivative of x minus 3 is just 1. So far, I have low D high less high D low. Draw the line, and down below, the bottom squared will go. So there's your quotient rule. Let's clean this up. So we have x minus 3, and I'm distributing here, so this will be minus x minus 3 over, and I'm just going to leave this alone, x minus 3 squared. So we have f prime is equal to x minus x. So those cancel each other out. Negative 3 minus 3 is negative 6. So this is the derivative. Now we need to find the slope at x equals 4 because that's the x value of the point of tangency. So let's evaluate the derivative at 4. We have negative 6 over 4 minus 3 squared. So that's negative 6 over, well, 4 minus 3 is 1. 1 squared is still 1. So that's just going to be negative 6. So this is the slope that we were looking for. So now we have a point, and we also have the slope. So we're ready to write the equation of the tangent line. Y minus y, so that's y minus 7, is equal to the slope times x minus x1. So there it is. This is the equation of the tangent line. Okay, let's find the tangent line for this function at the point pi over 3 comma 2. So we have a point, but we need the slope. Let's find the derivative so we can find the slope. We have memorized that the derivative of secant is secant tangent. So now let's find the slope at x equals pi over 3 because that is the x value of the point of tangency. So we're evaluating the derivative at pi over 3. So this will be secant pi over 3 tangent pi over 3. You should have memorized what the tangent of pi over 3 is, but for secant, I think we will look at it as the reciprocal of cosine. So let's do this off to the side. What is the cosine of pi over 3? You should have memorized this is 1/2. So therefore, the secant of pi over 3 is going to be the reciprocal of this, which is 2. So that means we have the derivative of at pi over 3 is 2 times. And you should have memorized that the tangent of pi over 3 is radical 3. So this gives us 2 radical 3. By the way, I keep quoting values off of this chart and saying, well, you should have memorized this and we should have memorized that. Let's make sure this is actually true. So if there are some values on this chart that you don't know by heart, go ahead and pause the video right now and get your study on. Anyway, we had a point right from the start, and now we have the slope, which is 2 radical 3. So we are ready to write the equation of the tangent line. So point slope form, it's y minus y1, so y minus 2, is equal to the slope, so that's our 2 radical 3, times x minus x1, so x minus pi over 3. So this is the equation of the tangent line at the point pi over 3 comma 2. Switching gears a little bit, determine the points at which the graph of the function has a horizontal tangent line. So a horizontal tangent line means that the slope will equal 0, which means that the derivative will equal 0. So first step is to find the derivative. I'm looking at a quotient, so it's time for the quotient rule. So remember the poem, low d high, less high d low. Draw the line and down below, the bottom squared will go. So let's go through it step by step. Low means the bottom part of the function, so I write x minus 1. But it says low d high. D high means the derivative of the top part of the function. The derivative of x squared is 2x. So I have low d high less high d low. So high means just write the top function the way it is. And then d low means the derivative of the bottom part. But the derivative of x minus 1 is just 1, which I really don't need to write. But I will just so you can easily follow. So I've got low d high less high d low. Draw the line and down below, the bottom squared will go. So there's your quotient rule. Let's simplify this a bit. Let's start by distributing the 2x. So we will have 2x squared minus 2x, and then we have minus x squared. And for now, we will just leave the denominator the way it is. So I see some like terms over here. 2x squared minus 1x squared is just x squared. So now we have x squared minus 2x over x minus 1 squared. So this is the derivative. But remember, the question is, where is the derivative equal to 0? The only way a fraction is going to equal 0 is if the numerator is equal to 0. So the derivative will equal 0 if x squared minus 2x is equal to 0. We will solve this by factoring, so let's factor out that x, and we have x times x minus 2. Using the zero product property, we're going to set each of these factors equal to 0, and we get x equals 0 and x equals 2. So these are the two x values that will give us a horizontal tangent line. but the direction said determine the points at which the graph has a horizontal tangent line. So we need an x and a y. So let's just find the y values that go with these x values. To find the y values, we're going to need the original function. So think of it this way. Y equals x squared over x minus 1. So let's start with the x value of 0. Okay, so at x equals 0, y will equal 0 squared over 0 minus 1. But of course, with the 0 squared, we just get a y value of 0. So putting the x value with the y value, we have our first point of 0, comma 0. But what about the x equals 2? So at x equals 2, y is equal to 2 squared over 2 minus 1. So that's going to give us 4 over 1, which of course is just equal to 4. Putting this x value with this y value, we get the point 2, comma 4. So these are the 2 points at which we will have a horizontal tangent line. Number 76 will be the same thing. We are looking for points at which the function will have a horizontal tangent line. I encourage you to pause the video and try this one by yourself. So as before, we will start by finding the derivative. Quotient rule, low d high. So the low is x squared minus 7. D high, the derivative of x minus 4 is just 1. Low d high less high d low. So here's high, and d low is going to be 2x. Draw the line, and down below, the bottom squared will go. Let's clean this up a little bit. So we have x squared minus 7. If we do the distributive property right here, that would give us 2x squared minus 8x. But then we have this negative sign. So once we distribute the negative sign, we will have negative 2x squared plus 8x. And let's leave the denominator alone. Combining like terms, x squared minus 2x squared is negative x squared. And then we have the 8x and the minus 7. And there's the denominator still. So this is the derivative. But the question is, where does the derivative equal 0? Where does the slope equal 0? A fraction is only going to equal 0 if the numerator is equal to 0. So this boils down to the equation negative x squared plus 8x minus 7 equals 0. So we're going to solve this by factoring. I don't like having a negative leading coefficient, so let's multiply everything by negative 1. So this will give us x squared minus 8x plus 7 is equal to 0. Let's see if we can factor this. So x squared will only factor as x times x. 7 will only factor as 7 times 1. If I need a negative 8 middle, I need both of these to be negative. And negative 7 times negative 1 is positive 7, so that works out. Setting each of these factors equal to 0, we get x equals 7 and x equals 1. but we need the y values that go with these x values. So we will think of it this way. Looking back at the original function, y equals x minus 4 over x squared minus 7. Okay, so we need to find the y value at each one of these x values. So at x equals 7, y equals 7 minus 4 over 7 squared minus 7. So y equals 3 over 49 minus 7. So that means y is equal to 3 over 42. So that's y equals 1 over 14 once you reduce that. So combining this x value with this y value, we have the point 7 comma 1/14. So let's do that again at the x value of 1. So at x equals 1, y equals 1 minus 4 over 1 squared minus 7. So y equals negative 3 over, well, 1 minus 7 is negative 6. So y is equal to positive 1/2. Combining this x value and this y value, we get 1 comma 1/2. So these are the 2 points at which we will have a horizontal tangent line. Number 77, last one, quite a little puzzle we have here. Find the equations of the tangent lines to the graph of f of x equals x plus 1 over x minus 1 that are parallel to the line 2y plus x equals 6. So we're finding equations of tangent lines, and we're going to use point-slope form. So that means we're going to need, for each tangent line, we're going to need a point, and we're going to need the slope. Let's start off by finding the slope. We need lines that are parallel to this given line. So what's the slope of this line? Let's rewrite this in the y equals mx plus b form. So subtracting x from both sides, we have 2y is equal to negative x plus 6. And then dividing both sides of the equation by 2, we have y equals negative 1/2 x plus 3. So what's the slope of this line? Negative 1/2. Okay, so we know that the slope of any of these tangent lines will be negative 1/2. So we need to find all of the places where the slope of this function is equal to negative 1/2. So of course, if we want to find the slope of this function at various points, we need to find the derivative. So looks like we're going to do the quotient rule. Low d high less high d low. Low is this bottom part, which is x minus 1. D high is the derivative of the top part, which is just 1. So that's low d high less high d low. High is the x plus 1. Let me put a box around this for a second. High d low. The derivative of the bottom part, again, is just 1, which you don't really need to write, but I'm just doing it for instructional purposes. So we have low d high less high d low. Draw the line, and down below, the bottom squared will go. So that's our derivative. Let's clean this up a little bit. Let's simplify. So we have f prime equals x minus 1. Distributing the negative sign, we have negative x minus 1 over x minus 1 squared. So we have f prime equals x minus x. Those cancel each other out, leaving -1 minus 1, which is -2. So we have -2 over x minus 1 squared. But we know that the slope needs to be -1/2, and this is a slope formula. So the question is, where does this derivative equal -1/2? So I'm just going to set this entire expression equal to -1/2. So we have -2 over x minus 1 squared is equal to -1/2. So you probably want to think of this as cross multiplying, I guess. So let me put this negative sign down here on the 2 specifically. So here I'm going to cross multiply. So I'm going to multiply these two together, and then I'm going to multiply these two together and set them equal to each other. You guys love to cross multiply, so now's your chance. So if I do the x minus 1 squared times 1, of course I'm just going to get x minus 1 squared. And then if I do -2 times -2, that's 4. So we can solve this by taking the square root of both sides. You have to be careful when you take the square root of both sides. The solution will be plus or minus. So don't forget that. So we will have x minus 1 is equal to plus or minus 2. Adding 1 to both sides, and I'm going to put this in the front, I get x equals 1 plus or minus 2. Okay, so 1 plus 2 is 3. 1 minus 2 is -1. So these are the two x values where we will have a slope of -1/2. Let's keep in mind what we are trying to find. We're trying to find the equation of tangent lines. And for each tangent line, we need a point and a slope. We already have the slope, so we are looking for any points that we're going to find. That's an x value and a y value that we're going to need. So we just found two x values, but we need the y values that go with them. So let's do that over here off to the side. In order to find the y values, we need the original function. So that's x plus 1 over x minus 1. So y is equal to x plus 1 over x minus 1. So let's break this down according to each x value that we have. So at x equals 3, y will equal 3 plus 1 over 3 minus 1. So that's going to be y equals 4 over 2. So y equals 2. So that gives us a point, x and y, of 3, 2. Our other x value is -1. So at x equals -1, y equals -1 plus 1 over -1 minus 1. But that is 0 over -2, which is 0. So that gives us a point x comma y, -1 comma 0. So we have these points, and don't forget we already knew that the slope, just going to squeeze it in here, we already knew that the slope was -1/2. So with this information, we can go ahead and write two tangent line equations. So let's see, tangent for this one, and we'll have a tangent for this one. We are doing point slope form. So we're going to do y minus y1 is equal to the slope times x minus x1. So here is our first tangent equation. And then doing it again for this point slope combo. So y minus y1, well that's just y minus 0. So I'm just going to put y. And then here comes that slope. And then x minus x1. Minus negative 1 is plus 1. So I'm going to put that. So this is the other equation of a tangent line. So that's it.